Welcome to EMR Physics. I am Raju. 12th Standard Physics Unit 1 Electrostatics la இப்போ நம்ம பார்க்க போற டாபிக் electric potential due to a point charge. Question எப்படி கேட்பாங்க அப்படினா derive an expression for electrostatic potential due to a point charge அப்படினு கேட்கலாம். Now let us see how we are going to derive the expression for the electrostatic potential due to a point charge. Let us consider a unit positive charge, unit positive point charge plus Q. P is the point at which we are going to find the electric potential. It is at a distance R from plus Q. அதாவது plus Q is the point charge and P is a point. This point is at a distance R from plus Q and at this point we are going to find the electric potential. அதாவது இங்கே plus Q ங்கிறது point charge, P ங்கிற பாயிண்டில் தான் நம்ம electrostatic potential கண்டுபிடிக்க போகிறோம். இந்த பாயிண்ட்டு R ங்கிற டிஸ்டன்ஸில் இருக்குது. Now we know that electric potential is the work done in bringing a unit positive charge from infinity to a particular point. அதாவது இன்ஃபினிட்டியில் இருந்து ஒரு பர்டிகுலர் பாயிண்ட்டுக்கு நம்ம யூனிட் பாசிட்டிவ் சார்ஜை மூவ் பண்ணுறதுக்கு எவ்வளோ ஒர்க் பண்ணணுமோ அதுதான் எலக்ட்ரிக் பொட்டன்ஷியல் அட் தட் பாயிண்ட். இன்ஃபினிட்டியிலேருந்து இந்த பாயிண்ட்டுக்கு ஒரு யூனிட் பாசிட்டிவ் சார்ஜை மூவ் பண்ணணும். அதுக்கு நம்ம என்ன பண்ணணும், ஒரு ஒர்க் பண்ணணும். That work is the electric potential at this point. Why we have to do the work? Because here we are having plus Q and we are moving a unit positive charge. அந்த ரெண்டுக்கும் இடையில electrostatic repulsion இருக்கும். Against the electrostatic repulsion we have to do the work and that work will be stored as the potential at this point. Okay. Now we know the general formula for the work done. dW is equal to F vector dot dr vector, force into distance. Here the force is the electrostatic force. Electrostatic force is given by F vector is equal to, the more general formula is 1 by 4 pi epsilon 0 Q1 Q2 by R square into R cap. In our case Q1 என்னது, Q, that is a point charge. நம்ம எந்த சார்ஜை மூவ் பண்ணுறோம், ஒரு யூனிட் பாசிட்டிவ் சார்ஜை மூவ் பண்ணுறோம். ஸோ Q1 is equal to Q plus Q and Q2 is equal to 1 because we are moving unit positive charge, 1 coulomb. So substituting this we will get F vector is equal to 1 by 4 pi epsilon 0. Instead of Q1 we can write Q. Q2 is 1 by R square into R cap. R cap is a unit vector which gives the direction of the force F. So we can write dW as, now dW is equal to 1 by 4 pi epsilon 0 Q by R square R cap dot dr vector. Now we have to calculate the total work done in bringing the unit positive charge from infinity to that point P. Therefore that is nothing but the potential. So potential at P, Vp is nothing but total work done. So for finding the total work done we can use this integration technique from infinity to P. இன்ஃபினிட்டியில் இருந்து Pங்கிற பாயிண்ட் வரைக்கும் யூனிட் பாசிட்டிவ் சார்ஜை மூவ் பண்ணுறதுக்கு எவ்வளவு ஒர்க் பண்ணணும். dW will be equal to integral infinity to Pங்கிற பாயிண்ட்டு 1 by 4 pi epsilon 0 q by r square r cap dot dr vector. In this case, the point charge is plus q and unit positive charge. Therefore, there is a force of repulsion. Therefore, we can put a negative sign here, and similarly we can put a negative sign here. So, we can write the reason for adding the negative sign. The negative sign indicates the force is repulsive. Therefore, from here Vp is equal to minus 1 by 4 pi epsilon 0 is constant, that can be taken out, and q is constant, so that can be taken out from the integration, and here you are having infinity to p, and inside 1 by r square r cap dot dr vector. So the potential at that point Vp, potential at point P is Vp is equal to minus 1 by 4 pi epsilon 0 q integral infinity to P 1 by r square r cap dot dr vector. Dr vector can be written as dr into r cap. So magnitude into unit vector. So here now you are having r cap dot r cap. R cap dot r cap is 1. Therefore, this is equal to minus 1 by 4 pi epsilon 0 q integration from infinity to P 1 by r square dr. Since r cap dot r cap is equal to 1. Now this is minus 1 by 4 pi epsilon 0 q dr by r square is equal to minus 1 by r infinity to P, since dr by r square is equal to minus 1 by r. So this is equal to minus 1 by 4 pi epsilon 0 q. After substituting the limits, you will get minus 1 by r. So minus of minus is plus. So Vp is equal to potential at P is equal to 1 by 4 pi epsilon 0 q by r. So this is a expression for the potential at a point P due to the point charge. So this is the expression for potential due to a point charge. We can write some important points regarding the electrostatic potential due to point charge. That is, first is electric potential or electrostatic potential due to positive charge is positive. Number 2, ரெண்டாவது பாயிண்ட், electric potential due to negative charge will be negative. In this expression, here you are having r in the denominator. So as r increases, which means that as the distance increases, potential decreases. So the next point here is electric potential. Electric potential decreases as or increases. So when R tends to infinity, potential tends to 0. So these are the important points regarding the electrostatic potential. So this is a answer for the question.